Today we're going to solve kinematic motion problems on an incline. Let's say you have an object moving along a frictionless incline, like a skier going down a slope. As you imagine, the velocity of the skier is going to be pointing down the slope. Since the skier is going to be speeding up, the acceleration and the velocity are going to point in the same direction, and so the acceleration is also pointing straight down the slope. The next step in any kinematics problem is to assign a coordinate system. If we use our standard coordinate system, you can see that neither the velocity nor the acceleration point in either the x or y direction. But remember, you can choose your coordinate system however you want. So if we rotate the coordinate system so that x points straight downhill, now both the acceleration and the velocity point only along the x direction, and we can just ignore the y direction. If we do this, there's a simple equation that will tell us what the acceleration of the skier is going to be. The acceleration in the x direction is going to be g times sine theta, where g is the acceleration due to gravity, and theta is the angle of the hill. Let's talk about that plus or minus though. Plus is if the acceleration is pointing in the same direction as x, because as you can see, if a is pointing in the opposite direction, then the acceleration is going to have the opposite sign. Let's look at an example. A skier starts at the top of a 120 meter long run. The slope of the hillside is 11.5 degrees. We want to know how fast they're going at the end. The first step is going to be to find the acceleration given the angle. Pause the video and see if you can do that now. Our acceleration is pointing in the same direction as the x-coordinate, so we're going to use the positive value for acceleration, plugging in our number of 11.5 degrees for the angle at 1.95 meters per second squared. After that, this is a standard kinematics problem, as long as you remember that the x direction is along the hillside. Since we're looking for the final velocity, we're going to use the equation that has that as its unknown, and the initial velocity, the acceleration, and the change in position as its known values. Little algebra and plugging in values gives us a final velocity of 21.6 meters per second. But what if you know the acceleration and you want to know how steep the hill is? In that case, we just solve our equation for the angle. Like in this example, try to find the angle of inclination of the hill. Pause now. How did that go? Make sure you're in degree mode, and we see that the angle is 23.3 degrees. We only solved for the acceleration in this video because once you have the acceleration, incline problems are just like any other kinematics problem.